Okay, so you want to know factors of like a number. So you know what factors are, right? I taught you Jingam, right? Do you remember? Um, Factors are whatever numbers that divide a given number. For example, okay, let me get a pen here to write things down. Okay, here. Okay, so for example, you have 6. Then whatever divides 6 and remainder should be 0. So whatever divides the 6 is 1, 2, 3, 6. So we say there are 4 positive factors of 6, right? So there are 4 number of factors. 4 number of factors. So, but for example, what if you want to get a factor of 8? You are going to look for whatever numbers that divide 8. That's going to be 1, 2, 4, 8. So there are also four factors, 4 number of factors for 8, right? And then what about 10 though? 10 we have 1, 2, 5, 10 that divides 10 exactly. So there are also 4 factors. But what about number like 3? Then we have 1 and 3. What about number 5? Then we have number 1 and 5 for factors of 5. What about number 9? 9 we have 3 factors. 1 and 1, 3, 9. Then as this number as this number gets larger, there will be more factors. So counting everything like this wouldn't be so effective. So I will teach you how to count this effectively. Okay? So hold on a second, please. Two. I want to erase everything, but it doesn't really work. Okay. Ah, okay. Okay. I still don't. I'm still in the middle of figuring out how to use this application. But well, so for 6, how do you find factors out as fast as you can? So 6, you get a prime factorization of it first, which is 2 times 3. Okay, and then you get a prime factorization 8. Then you know what a prime factorization is. Then 8 is 2 to the third power, so 2 cubed. And 10 is 2 times 5, and 3 is just 3, right? Because there's only, when you get a prime factorization, you are going to write down factors as prime numbers. So 3 is the only prime factor for 3. So 3 is just 3. 5 is also 5. So prime numbers, you don't have, I mean, they do not have a prime factorization. I mean, they do have a prime factorization, but they are themselves. 3, the prime factorization of 3 is 3. Prime factorization of 5 is 5. Prime factorization of 9, however, 9 is not prime number, so 9 is not a prime number. So this is 3 to the second power, which is 3 squared. So how do you find out how many factors do these numbers have? So follow this with me. So it says, take a look at this thing. We call this the exponent, and we call whatever is down here base. This is base, and we call this part exponent. Exponent. Okay, I don't have space to write this down. So you just simply add +1 to this exponent, then you get the number of prime factors. So for example, 5 is just 5 and 3 is just 3. What that means is 3 is multiplied just once, 5 is multiplied just once. Here, 3 is multiplied twice. Therefore, like I said here, you just add 1 to the exponent. So it's just +1. And it's also just +1. So the answer here is 2. And the answer here is 2. As with 3 and 5, all the prime numbers have two number of factors, which is 1 and itself. That's the definition of that's the definition of prime numbers. Okay, and now what if there are two numbers? Okay, let's finish with this first. So it's 2 cubed and +1. You just add 1 to figure out how many factors does this number have. So this is 4. So this is exactly 1, 2, 4, 8, right? And then now you have 2 and 5 and 2 and 3. So now what do you do with exponents? So exponents here, when we do not see anything, it means it's just 1. It means it's just 1. In the same manner, you are just going to add +1. Then it's just +1 and +1. So this becomes 2 and this becomes 2, right? Since they are connected with multiplication here, they're connected with multiplication, right? They're connected with multiplication. You just simply multiply them and it becomes 4, okay? And now in the same manner, 2 times 3 is 1 and 1. Their exponents is 1 and 1. Simply, you are just going to add 1 to each exponent. Then it becomes 2 and it becomes 2. Okay, so the first part becomes 2 and the first part becomes 2. Okay, and then since they are connected with multiplication, you just need to multiply 2 times 2. So you have 4 number of factors. Okay, so this is pretty much everything. Okay, let me just generalize this for you. But I do not know how to erase everything here yet, because I do not actually know how to like. Okay. Uh. Okay, it doesn't work. Can you hold on a second, please? Okay. All right. Um. All right. I have. Okay. Let me summarize everything for you. I do not have a lot of time, so I will go quickly here. Hold on a second, please. Fill, then black. All right, it's blackboard, and then I get my pen here. So okay, so for example, you have number b, and then you prime factorize this number, and then you have a to the p power and b to the q power and then c to the r power. So the number of factors of b is p plus 1, q plus 1, and then r plus 1. Okay? But you need to be very careful because a and b and c they need to be prime numbers. Okay? So for example, quickly, you have you need to get like a number of factors for number 135. Then you quickly need to get a prime factorization of this number, which is I think 5 and then 5 times 2 10 and then it's 27, right? So 3 cubed, right? 27 times 5. So the answer is you just add +1 and 1 plus 1. When there's nothing, just +1. So 2 times 4, there are 8 factors.